let's look at our next set. First, next question is on this integral. So again, you're looking for something in a parentheses. Well, there's a big parentheses right there, but there's also a parentheses inside of the radical. Right. So when you're picking your u, you want it to be something that you can easily take the derivative of, because that's going to be a derivative column. If your u involves a bunch of complicated stuff, then you need to pick something else. Right, so this is now my integral. We want to get rid of that dx, so I'm going to take the derivative of the u that I picked. Right, so you multiply the dx to the other side. Du over 2x is equal to dx. So I'm going to plug it in right here. Du 2x. I'm also going to start cleaning this up. This is 5x. This is u to the 1/2 power. All right, so now by cleaning up, by canceling out the x's here, I am left with just the coefficient 5/2 that I'm going to pull out front. U to the 1/2 power, and then du. All right, so this is my derivative column. This is my integral column. Okay. I started by picking u is equal to x squared plus 10, which is going to take the place of the inside of the radical. And I noticed that, well, I have too many variables here. So usually you want to get rid of dx first, and then usually the rest of it kind of gets taken care of. You want to get rid of the dx by taking the derivative of this u component and essentially solving for dx, which I do right here. And now that the x's are gone, I'm allowed to integrate. Right. Our rule here, so 1/2 plus 1 is a 3/2. Right. You add 1 to 1/2, giving you 3/2, and then you divide by that exponent. So 2 times 3/2 is just a 3. So you get a 5/3. Plug the u back in, and then plus a constant. So this would be your answer here. And then if you want to check your work, right, 5/3 times 3/2, x squared plus 10 to the 1/2 power times 2x. Right, so all these coefficients clean up. 3's cancel, 2's cancel, you get a 5x. And then this is under a radical, x squared plus 10, which, oops, why is that a 10? It should be, all right, these should all be 11s. Right, which does match the original question. Right, let's look at number 5. So something, remember that when you're doing this, right, so this is an example where I'm going to pick a u that does not work. That's like the innermost component is 6x, right? So if we let u equal to 6x, then du over dx is equal to 6. So du equals 6 dx. Right. So this is my derivative component. We've got ln of, let me erase this just so you see. Right. So this 4th power is taking this entire thing. So what you end up with is ln of u to the 4th power divided by 5x. And then if I plug in the dx here, you get a du over 6. Right. So notice that even though there's a bunch of u's here, we still have this x right there in the denominator that did not get cleaned off. Right. So if you end up with getting something like this, what this means is try another u. right? It's perfectly fine to not, everything here is mathematically correct. It just does not work, right? So something that I'm going to point out in this class, right? Ultimately, we do not want to integrate ln because there's no rule to go backwards from ln. So little side note here, if you have an ln in the integral, right? Basically, this part hides all the stuff that you don't want to integrate. So if I let u equal to ln of 6x, and then take a derivative, oops, right? Du over dx would be 6 over 6x, right? Take the derivative of ln of something is 1 over that something times the derivative inside, right? So this cross multiplies. Du 6x du is equal to 6 dx. And if I solve for dx here, you get x du is equal to dx. Right. So what did I do here? So I picked my u to include the ln, took the derivative. The derivative of u is du dx. Right. You're going to have to get used to that notation because that's what's going to clean off the integral. So take the derivative of that. You cross multiply 6x times du equals 6 times dx. You divide both sides by 6. You get this equation. All right, so we are down to this integral, right? We let I'm going to highlight the u that I picked. Right? That whole thing is u, which means that the numerator is u to the 4th power over 5x. And if you put the du in, comes x du. Right, which is great. So this is treated as a numerator. So as this x and this x cancels each other, you're left with u to the 4th over 5 du. All right, so I can pull out that 1/5 as a coefficient, u to the 4th. And now I'm going to do the power rule, right? Everything is now in terms of just one variable, in this case, one variable u. 1/5 u to the 5th over 5 plus a c, right? Remember, you add 1 to the exponent. Right, so this is 1 over 25. You plug the u back in. In this case, the u was ln 6x. And this would be your answer. And then let's check our work. Right, this is a chain rule, so you bring the 5 down, leave the inside alone. That's the derivative of the inside. So the derivative of ln of 6x is 1 over 6x times 6. All right, and then let's do some cleaning up. This 6 and this 6 cancels each other. This 5 and this 25 cancels each other, giving you 5x. Not quite cancels each other, but you end up with 5x in the denominator. And then you get ln of 6x to the 4th power in the numerator, which matches our original problem. All right. Next example here, we've got a function that has an exponential, and so there's one set of parentheses. We have this big one, which doesn't really help if you let that equal to u. But what we do have is also an exponent here, right? So we're going to let u equals 10x to the 4th. Right, when you take a derivative of the 4th power, you get a 3rd power, so it kind of sets it up nicely. All right, so if you let the exponent be your u, we get 5x cubed e to the u du. And again, we want to get rid of, oops, sorry, that's a dx. All right, we want to get rid of that dx, and we're going to do that by working with the u that we picked. du dx is 40x cubed, cross multiply, and then you divide by this to get rid of it. Solve for dx, which plugs in right here. All right, so this is great because now that the x cubes are going to cancel off. This x cubed is going to cancel with this x cubed. So we end up with a 5 over 40, which is 1/8, which I can pull out front. That should be a u, not an h. Right, so remember that the derivative of e to the u is e to the u, so the integral of e to the u is also e to the u. So 1/8 e to the u plus a constant is my answer. Oops, sorry. Before I declare that as my answer, don't forget to plug the u back in. Right, so that would be my answer there. And then if we check our work, right, so take the derivative of 10x fourth, that's a 40x cubed, e to the 10x to the fourth. All right, so 8 divided by 40 gives me 5. And if you look at your original problem, this does match the integrand, so I know that this is a correct answer.